Hey everyone, Tim here from SnapAttack. Let's dig into this week's threat snapshot. So we're going to cover two emerging threats today, and the first one up is MinIO. So if you're familiar with Kubernetes and Docker applications, especially if you're trying to take them on-prem, you've probably seen or heard of MinIO. It's a S3 compatible storage system, so if you need to have objects stored in something like AWS S3, but you don't have the luxury of the cloud, this can be a drop-in replacement. Bit of an oversimplification of what it does, but that just gives you the gist. So what's really interesting about this threat in particular is there's two different CVEs, both of which were released probably about 6 months ago. They were added to the CISA's known exploited vulnerabilities catalog back in April of this year. And we're just seeing, again, a lot of activity now with internet-facing MinIO servers being exploited using a combination of these two CVEs, which do lead to remote code execution. And again, just given the nature that this is a file store, there could be sensitive, files, data stored within that system. So it gives a lot of access. So wanted to take a closer look at this. So this is just a news article here. If we want to go to the source, which I always like to do, Security Joe's has been writing up a very good detailed blog post about, again, MinIO, about the threat itself and some of the activity that they're seeing. This does affect both the Windows and Linux versions of MinIO. So this is something to definitely take a look at. It is a very wide-reaching exploit. And again, there's a lot of public-facing versions of this. So I think they've scanned Shodan. You'll see, 50,000 plus hosts vulnerable. So, obviously solution patch these things, but let's take a look. What does this actually look like? So we're going to be using the Evil MinIO POC. Again, this is a little bit older vulnerability chain. This POC was released 6 months ago. It's not necessarily sure that this is the exact POC that's being used by attackers and weaponized. They certainly can modify these a little bit, but this does cover what actually the chain is. And there's two pieces to this, which you can actually see here in their documentation. So the first one, which again is pretty interesting, is part of the setup process. There's this Bootstrap API, and if I can zoom in a little bit more, you'll probably be able to see it. They have this post request here to it, and it leaks all of the environment data. And that includes environment variable called MinIO secret key with your secret key here. So you can use that key to do a lot of other things, including staging a malicious software update for the MinIO server, which is what they're packaging up as a backdoor, which gives them code execution. So again, two different vulnerabilities here, but chained together make a very interesting POC. So we've got this threat. We have it captured in SnapAttack. Let's take a look here what this looks like. We do have a Windows host that is running MinIO. Not really a whole lot here to see on the victim machine. Let's kind of focus in on the attacker. So have a couple of stages here with this exploit. So we're going to hop ahead a little bit in the video. The first step, like we said, is going to be to get that secret key variable. So again, this is just a very simple, we can do a curl post command, and then we're going to find and extract that MinIO secret key. Nothing that's secret here. We made our MinIO secret key MinIO. And then again, we can stage and create that malicious, packaged upload. So you can see here some of those commands that we're using. We're putting that together, and fast forwarding a little bit, we can upload that to the server, and then we can use this backdoor. So there's a GET request looking for a live, and then we can put our commands in here. So who am I, ipconfig, things of that nature. Again, if I were going to be writing a backdoor web server, I probably wouldn't be putting the stuff in GET variables. That's going to show up in your web logs. But that does make it a little bit easier to detect versus, hiding it in post data or obfuscated. So again, very simple combination here, but very effective. Good news is there are lots of detection opportunities for this. Taking a little look here on the process graph, what this typically looks like. Again, this would be very similar on Linux or Windows. Just the differences on Linux, you're probably going to seeing, binsh or bash that's going to be spawning instead of CMDs and PowerShells, but we've got that MinIO process that is running, and then you're seeing it spawning our CMD tac-c, and then it's going to be running whoami, ipconfig, other things of that nature. So again, we've got basic code execution, and then you can use your living off the land techniques from there. You could download a second stage C2, lots of different opportunities. So how do I detect this activity? How do I hunt for this? A couple different chains and ways that we can look at this. So first one is going to be the initial CVE that's looking at that verify command. If you've got access to web logs or if you've got access to network data, you can look for post requests to that verify. Remember, on the unpatched versions of this, it is always going to be leaking those environment variables. So if you see this request, you can assume that the attacker has access to that sensitive secret key. And that also leads to the next phase of the attack, which, again, you could be looking for this as a correlation search. That next piece, like we said, is going to be that malicious update. So we can see that post request to the admin update. And again, you're going to see an update URL where we're going to host that update file, and it's going to pull that down. So we can see what that looks like here. That's that stage 2. Again, really, if you want to focus in on more of the post-exploitation piece, we always talk about, parent-child processes and things. So we can take a look and see, is there any process that, we have with that MinIO process name that is spawning things like your CMDs, your PowerShells. Really, again, this shouldn't have any child processes listening for it. So this is a good way to look for that. So that's, again, a nice evergreen detection that you could use, that you could deploy with one click to, one of your integrations like SentinelOne, Elastic, Microsoft Defender. Next threat that we want to talk about today is this new, I guess it's a password dumping tool called PPLBlade. I know we've talked about Protected Process Lite quite a bit, and how Windows has done hardening to protect LSASS and protect credential dumping. So PPLBlade, in a sense, isn't a lot different than some of the other things that we've seen. They're using a kind of tried and true technique. If you're familiar with the LUL drivers project, you've probably seen, and I know we've talked about the Process Explorer, Process Explorer, this driver here. Again, it's an older version, but that one does allow you to open up and obtain additional permissions, which can bypass PPL. So that driver, again, does have to be installed on the system, and then this is going to communicate with that to dump LSASS. Where PPLBlade gets a little bit interesting is they're going to obfuscate that dump before they drop it to disk. Again, it's one of those things where this is a cat and mouse game between the attackers and the defenders, where defenders see, oh, I've got what looks like an LSASS dump written to disk, and I'm inspecting the file, so Windows Defender would see that. But again, because we are obfuscating the file and it's looking at the contents when it gets written to disk, it doesn't see anything intelligible, so it just ignores. So again, it's that fun cat and mouse game that we're playing. So that's really probably the more novel piece of PPLBlade. Still wanted to take a look at that here in SnapAttack. Again, we can see some of these detections. Again, not surprisingly, again, vulnerable driver loads or LUL drivers, creating a dump extension. Again, nothing new here. And then we've got a couple specific for PPLBlade as well as an attack script. So I can hop here on the video. Not a whole lot that is super interesting with this one. We can go ahead, we can play the video. We're just going to run PPLBlade. They've got some fun commands like do that LSASS thing with obfuscate, and you're going to see a little bit of debug output, but really here you're going to see just like we've got that PPLBlade dump file. So again, pretty boring on the process graph view, pretty boring on the system, but again, getting those credentials out of memory, being able to use that for passing the hash, being able to crack those credentials, leads to a lot of other phases in the kill chain. Again, good news is this is highly detectable, including some of our more evergreen detections. So let's talk about a couple of these opportunities here. So there is the PPLBlade hack tool detection that we have, which again is going to be looking for, process events and command line usage of PPLBlade. looking for things like do that LSASS thing, looking for obfuscate, looking for other parameters. So this is definitely an easy low-hanging fruit option. Looking a little bit more specifically at the inner workings, and I know we've seen this in some of the other tools that are using that vulnerable driver. You have to, again, install that driver, so you're going to see a service installation. We can take a look at a Windows event 4697 for that. We can also take a look here, PPLBlade, this is the kernel level service creation, where we're going to be able to see that. This is a registry event, taking a look for that that driver that's being installed. So that is another opportunity here. Last thing, just wanted to highlight, again, we do have attack scripts. These are a little bit newer to SnapAttack, but it does allow you to test your defenses and see, hey, am I covered against PPLBlade? So, we can actually take a look at the attack script. We're just going to download and run PPLBlade. Very simple. We could go ahead and with the click of a button, we can launch an attack script, run that across our tools, see if our EDRs or SIMs can pick this up. If we don't, we can deploy these detections and make sure we're covered. So that's our threat snapshot for this week. It's a weekly series. Like, subscribe, comment, and we'll see you next time.